Hello, my name is Shahwar and I'm a part of the group Innovation 2020, which has been proposed to do the greenhouse project. So let's start with the project. I'm going to present you what we have done with this greenhouse so far. The first sensor that we have put it on is a light sensor. Basically, it receives the light from the ambient light, and it goes. The Arduino receives the input from the light sensor, and accordingly, it turn on and turn off the light. So I will going to show you now. As you can see, my finger is presenting a dark light at the moment and the light is turning on, and if I'm taking my finger off, the light is off. This is the first feature of the greenhouse that we have put it on. The second one is a moisture sensor. This should be inside the soil, which basically check the water level, if there is enough water in the soil. At the moment, as you can see, I just put this moisture sensor inside the water for only purpose of showing that everything is working fine. If I'm taking out this moisture sensor, the pump will start fueling all the water inside the greenhouse. So this is the main purpose. If there is enough water inside the greenhouse, inside, or if the soil is enough wet, the pump will not turn on. So this is the first two features that I'm going to present.
Continuing with the video, my name is Shahwar and I will present the rest of the features of the greenhouse. The additional features that we have on our greenhouse is our DHT11 sensor, which checks the humidity and the temperature inside of the greenhouse. We have taken it out so that we can play with it, so that we can show the value is changing, but originally it was meant to be inside of it. So as you can see right now on the monitor, we can see that the temperature inside of the greenhouse is 45 degrees and the humidity level is 32%. And based on that, the red LED has been turned out because we set it so that if it's above 30 degrees, it will turn red. And we can see that the hatch is closed and also the fan is stopped. So if I put a wet cloth on the sensor, we can see on the screen that the temperature is starting to decrease and the humidity is increasing now. As the humidity hits above 60%, we can see that the hatch opens so that it can expel the excess of humidity from inside the greenhouse. And if we wait a bit more, we can see that if the humidity level reaches above 80%, additionally the fan starts to turn to take out the air because it has a lot more humidity level than it should. So we have a fan taking out the humidity as fast as possible. And moving to the second part, we can see now that the blue LED has been turned blue because, as you can see on the console, the temperature has decreased below 30 degrees, which is the ideal temperature for a greenhouse. So originally we was meant to have a heating mat below the greenhouse, but because we couldn't show on the video visually that the heat was increasing, we decided to put a LED to visually show it. So if that blue LED turns on, it means that the heating mat is turned on. So when the heating mat is turned on, it will heat the inside of the greenhouse until the temperature is high enough for the plants to be maintained, and then it will turn the red light on again. Continuing with the video presentation of our project, now I will begin to explain the coding part of the Arduino that we had. Starting off, we used two libraries, which was the DHT and the server library, because we used the DHT11 sensor and the servo motor, and these two libraries was important for these components to work. After that, we have a declaring scope where we have declared all the pins and used more user-friendly variables for them. For example, the pin number 8 is replaced with servo pin because it is more user friendly, because we can understand what that pin is used for rather than just putting a number and guessing what that number represents to. For example, this could be the LDR pin or it could be the LED pin. So if you use variables that are more easier for us to understand, then it is better for us to program them because we remember what each variable is. After declaring all the variables and replacing the pin numbers for them, we have the void setup, which is the part where we declare what each pin is used for. Starting off, we have the relay bulb pin, and this is a pin that is connected to our relay, and it changes the position of the relay from one place to another. So as it needs to have any output from the Arduino, it is set as an output because it is an output device. After that, we also have the LDR pin, which is the photoresistor, and because this pin is used to get information from the ambient light, it is an input, so we have declared it as an input. And we did the same for all the rest of the components, which is the pump, and we have the relay pump pin and the soil sensor for it. We had also declared a servo motor, and it was attached to the pin number 8, so we had declared that the servo motor that we had declared before is attached on pin number 8. After that, we have the pin mode for the fan relay, and this is an output to turn off and off the fan. And also we have the blue LED and then red LED, and these two are outputs so that the Arduino turns them on and off. Continuing to the main body of our coding part of the project, we have used mainly if statements to control the behavior of the devices connected to our greenhouse, starting with the bulb, which is used to heat up and give light to the to the interior of the greenhouse. So starting off, we have created a variable called LDR status, and this variable obtains its value from the LDR pin input. So whatever the photoresistor is receiving from the exterior is set on the variable LDR status, and then this status is compared if it's bigger or smaller than 500. If the LDR status is less than 500, then it will turn on the relay and it will turn off the relay, which will trigger the bulb to turn on. And we have also originally we also had a problem with the bulb because whenever something was going on top of the photoresistor, it was turning on and off the bulb quickly. So we had to put a delay of 2 seconds to it so that it will not change the status of the bulb very fast, which could break the bulb. So that's why we had put a delay on it. After that, we have also got serial prints commands, which are used to display the condition of the sensors and the hardware, which is the bulb, on the serial monitor for us to know what is happening. And in our case, if the bulb is turned on, then it's a message saying it's too dark, bulb is now on, will be displayed on the serial monitor so that we know that the bulb is being turned on. And on the other hand, the else statement is used, so in case this condition is not met, which is that the LDR status is less than 500, so if there is enough light, then the relay bulb pin will be set to high, which means that the relay will trigger on the switch of which it will trigger off the switch by disconnecting the power to the bulb, and a message will be displayed on the serial port saying there is enough light, bulb is now off. Continuing with the soil moisture sensor and the pump, we have a variable called soil sensor value, which obtains its value from the soil sensor, and based on that it checks if there is enough water inside the soil or not by checking if it's low. So for example, if the soil sensor detects that the moisture inside of the soil is low, then it will trigger off the relay and it will set the the condition to low, which is reliable pin to low, and this will trigger the pump to switch on and water the soil, and it will also display a message on the screen saying that the soil is being watered now. In the other hand, if there is enough water and the soil sensor detects that there is enough water inside the soil, then it will change the position of the relay to high so that the pump is turned off, and a message will be displayed on the serial monitor saying there is enough water in the soil. After that we have the configuration for the servo motor and the fan, and in this case we have a variable called chk, which we shorted it for checking the condition of the DHT, and this variable collects the readings from the DHT sensor, and after getting the readings from the DHT11 sensor, then it will display serial print the temperature inside the greenhouse is in Celsius is, and then it will obtain the value of the temperature and display on the screen, and also the variable of the also the value of the humidity and display it on the screen, and it does this on intervals of 1 second so that the Arduino board has time to update its inputs from the sensor. After that we have if statements that are used to control the condition inside the greenhouse based on the temperature and the humidity. So if the humidity inside the greenhouse is less than 60, then it will close the hatch by turning the servo motor on a position of 180 degrees, which closes the hatch, and also it will turn off the fan by setting its condition to high, and this is because we don't need the humidity inside of the greenhouse to escape to the exterior. After that we have the if statements for when the humidity inside the greenhouse is more than 60%, which is not an ideal amount. So what the servo motor does is it changes its position to 90 degrees, and in this position it opens the hatch so that the excess of the humidity inside the greenhouse it's expelled out of it, and when this condition is met it returns back to closing the hatch again. Finally we have the scenario when there is more than 80% of humidity inside the greenhouse, which is a very high level. So what we do is that we use the fan relay pin and we turn it to the position of low, which means that it will trigger on the fan so that it can take out the humidity inside the greenhouse as quickly as possible compared to the first method, which was just opening a hatch, which is slower. So we had put a fan inside of it so that in extreme conditions it can take out the humidity as quickly as possible to not damage the plants that are growing inside of our greenhouse. Finally we have the temperature control statements, and in this uh, case it obtains the temperature from the DHT sensor, and then the temperature is compared. If it's lower than 25%, the blue light will be turned on, and the red light will be turned off, and this means that the inside of the greenhouse is cold. If the temperature is higher than 25%, it will turn the red light on and turn off the blue light. And originally we had planned to replace this blue light, the red and blue light, with relays which was turning on and off a heating mat, but because we didn't manage to get a heating mat, we just used LEDs to represent the same scenario, the same condition, so that if the blue light is on, it means that it will, in a realistic world, it will turn on the heating mat, and if the red light is on, which means that the temperature is higher than 25 degrees, then it will turn off the heating mat. And this concludes the coding part of our project, which controls all the components to make everything work according to our configurations. Thank you for watching our video presentation.